getting started with blockchain. So blockchain is basically a chain of blocks, and we can explore every block, every computer on a special website called Etherscan. This is especially for Ethereum blockchain and the Ethereum blockchain explorer. This is the Ethereum blockchain explorer. We can see all the latest blocks that are mined, latest transactions that are happening, and these transactions are happening according to the contracts or something. Anything the contract, we can go to any address like here, right here. We have a contract. I already have a contract open here, but this is on Ringb. Ringb is a test net. So whenever a developer is trying to get into blockchain and doing something, he don't have to spend the real money, real gas on just testing the contract. So they can go to Ringb, and we have a lot of we have a lot of test nets here also. Okay, I'll just put the password. Okay, that will be correct. Yeah. So this is Ringb ETH and we have, these are the test nets, Robson, Cowan, Goril testnet. So we can go, this is actually my own localhost. So Ringb testnet, and we can go to these testnets. These are actually faucets, and we can request the development ETH on that. So if you want to request for Ringb Etherscan, so we can go to Ringb faucet. Okay. So we can go to the faucet and we can request a testnet ETH for our experimentation and stuff. So okay, let's get back to the blockchain. So blockchain, this is a contract, and this is not published and verified, but these are the transactions happened. So in this contract, only one transaction has happened, only the contract creation. So no function is called from this contract. Okay, let's get back to the basics. So this is the Ethereum blockchain. We'll go to a block. We'll go to block number this much. So there are 360 transactions happened in 18 seconds. That's what the record states. So we can go to a transaction also. We'll go to this transaction. Okay, this is loading really slowly. So I think this is mainnet. That's why it's loading. Okay, it's done. So the block height, this is the number of that block. So this is 909, 15, 20, 3909 block. And this is mined 34 minutes ago. They have got the reward of 2.075 ETH. So according to market, that is $1,500 approximately. So we can go to, that is almost $30,000 they got for mining this very block. And they have spent, like, gas, we can see the gas used is 87.68%. The gas limit was this much, and this is in GUI. Actually, this is in GUI, so this is not Ether they have spent. And base fee per gas, okay, we can see that. Yeah, the most important thing is the hash. So this is the hash of this very block, and this is the hash of its parents block. Like this, these two blocks needs to be connected. So the next block will store the hash of previous block as a record to be connected with it. So when we want to change the transaction data of this block, we need the transaction hash changes for this block also. So for the block number 2, the block number 3 will store its hash as a previous hash. So the block number 3, hash of block number 3 will also change. So we'll go to this parent block first. So here's the parent block. That was 909, this is 908. So you can see they have mined it, and they have mined it like 36 minutes ago. So mining a block is basically creation of a block. It's like creation of a set of transaction nouns, and okay, we can see the nouns. So here is a nouns, and so basically they have to calculate the hash, and once you calculate the hash, the block is mined. So yeah, so the parent hash is also this. This will be the hash of block number 907. So okay, now we'll see. Okay, so we'll see this is mined by Ethermine in 6 seconds. That's pretty fast computer you must have. And okay, we'll go to some contract now. We'll go to a transaction. We're looking at the blocks. So we'll look at this transaction now. Okay. So this is a transaction, and we can see the transaction hash is here. It is successful transaction. The block number. So after this transaction, this block got mined, and we can see the contract also. I don't see the contract. Yeah, input data. Yeah, this is not a. Okay, this is a contract here, right here. Yeah. So this is the contract, and we can see all these are the transactions where the blocks actually are calling the functions of this smart contract. So we can go to the contract. They have this green tick actually means they have verified and published the contract. So we can look at the contracts here. So they have, this is Solidity. Solidity is coded in Solidity. So we have a lot of files here. I don't know. Yeah, okay. We're not going to look at everything of that. So we can see the events. Events basically mean what kind of events are happening here. Okay, comments, actually the analytics, there should be a function call thing also. Okay, there are no comments. Okay, so I yeah, it's here. Read contract. In the read contract, we can call their functions. So in the smart contract, they have these kind of functions: maximum rollup, minimum rollup, batches, and these functions. If you want to call these functions, we can just go to write contract, and the writable functions will be here. Okay, where are these ones? Yeah. So append sequencer batch. So we can go to this. We can write this function, and please connect your Web3 provider. It will open up my MetaMask. Okay, how do I connect it? Maybe it should directly open my MetaMask. Okay. This is on Etherscan mainnet. I should go to Etherscan mainnet. Now it will be connected. Yeah, we can. Okay. It's not connected yet. Yeah. No, it is not. So I'll have to sign in or something. Okay, I'm not doing that. Okay, so that's how we explored the Etherscan. So we have explored the Etherscan blocks, we have explored the Etherscan contracts, and these contracts actually they can give you a lot of details about it. We can see the contract. If it is verified and published, we can see the code also. Otherwise, in this contract as such, we can go to contract, and here is the opcode. We can decompile this bytecode. We can decompile it to get a contract. Okay, decompile it. Okay, so this is the first time decompilation of this contract. Okay, there is a currently blocking. This is back. Okay, I don't know. Okay, so decompile is not working right now. So basically, this is Etherscan, and on Etherscan we have one Ether price is 1610. It's going up. That's good. Transactions are happening mid gas. Gas is 6QA. Gas actually means when there is a lot of traffic, you're actually bribing the network. It's not really bribing. It's just paying some money to get your transactions faster. So if you want to have some leverage over all the people that are going to all the blocks that are trying to get mined at the same time, the one with higher gas price will be mined first. So it's like queuing. It's like a queue, but you can pay extra money to get out of that. So that's all about gas. And this is for Ethereum. We'll make another video for Tezos blockchain also. On Tezos, it's very interesting. It's a different thing. It's a different blockchain. So basically, the protocol of connecting two blocks in Tezos is different. And the main thing is Ethereum is working on proof of work, and Tezos is working on proof of stake. So what proof of work basically means is if you are going to if you want to mine this block, now look at this. This is a 068 block. If you want to build the block and mine it at 069, we'll have to I mean, your reward will be basically decided on how much your computing power is, how much you're contributing to the blockchain. But in proof of stake, like in Tezos, there is no such criteria. There is actually how much stake do you own in the blockchain itself. So that's how the Tezos will work. So since there is no queuing, and so the gas prices are really low in the blockchains where we are using the proof of stake thing. But in proof of work, they have to use a lot of gas. They consume a lot of gas because it's a long queue. Everyone is trying to mine, and every vote is actually equal. But in proof of stake, the one who holds more stake, his votes will hold more value. So that's it. That's all for today on the Etherscan. So we can just change it here also. 969, maybe it will be mined till now. Yeah, it is done. It is mined. So we'll go to a fairly per number. We'll go to 100. Yeah, it is not blocked yet. Okay. So estimated target date. This is it, and it will be blocked after 33 seconds. Okay, we can go to 99. That must be blocked. 099. Okay, go. Yeah, this is blocked right like 14 seconds ago. So blocking is going on. Blocks are getting added up. The blockchain is growing infinitely. So it's very interesting. And the gas we can see right here is 7 Gwei. And you need to connect the MetaMask actually to any Web3. Okay, Ringp faucet is also open. Okay, we'll go. That's it for this video. I'll go for Ringp faucet and Goril faucet on another video. So thanks for watching.